This is Humayun Kabir, PhD candidate, University of Abdur Rahman. I am going to present a conference paper in 2020 IEEE Symposium on wireless technology and applications. The paper title is DRL-based Energy Efficient Radio Resource Allocation Algorithm in Internet of Robotic Things. The whole paper is divided into a few sections: introduction, objectives, related works, methodology, performance evaluation, and conclusion. Introduction. Robotic system is a cutting-edge, rapidly evolving technology that has assured a massive impact on several socio-economical areas that are not limited to industry, military services, agricultural, health, transportation, rescue operation, where actually humans are unable to reach safely. Internet of Things is an important as well as a realistic research area in which the concept has been applied in robotic system for communication, coordination, monitoring, and control the robots. That is called the Internet of Robotic Things. The architecture of IoT, it has three layers. One is perception layers, network and control layers, service and application layers. In perception layers, all robots, sensors, actuator, computer, and control unit are connected. In network and control layer, various routers, controllers, and servers are involved. In service and application layers, actually all apps for monitoring the process and control the agent and environment parameter are involved. We are going to do this research because IoT generates and process enormous quantity of information to operate all connected EUs. The capacity of IoT or IoT network and resources are limited. If we add the IoT gates more, to handle the overloaded IUEs, it increase the cost. That's why researchers are going to apply a different system that is called the dynamic radio resource allocation in cloud radio access provide, which gives a promising solution to overcome this problem. In CRN, it has two parts. One is BBUs, another one is radio, remote radio head, it is antenna. The objectives of this paper is to develop unique deep learning deep reinforcement learning algorithm based algorithm for RRA in CRAN environment by minimizing the total power consumption while meeting all user equipment's requirement. We have proposed DRL algorithm due to it is model-free algorithm. No data set is required. Accuracy is really high. The related work I am going to discuss in reference 11, 8, 9, 12, 14, and 16, traditional algorithm is applied to optimize the radio resource of RRH. In 21, the author actually applied the DRL algorithm to reduce the expense and improve the network resource utilization. In 22, the author applied a DRL algorithm to minimize the cache message and balance the communication load in 5G CRAN. In 23, the author applied DRL algorithm to minimize the consumed power in BBUs by maintaining the user QES. In 24, the author applied the DQN algorithm to improve the system efficiency and minimize the power consumption. In 20, the author applied the DQN algorithm to minimize the total power consumption by ensuring the user demand. The methodology, actually, this is the main figure of our presentation. Here, UEs are connected with RRH. This RRH is actually connected with BBUs. So we consider for presenting this problem mathematically, we consider RRH set is 1 to R, UE set is 1 to EU. The all notations are presented in this table 1. R and R. R is the set of RRAs, A is the set of active set of RRAs, sleep set of RRAs is S, and the transition set of RRAs is G. U is the index of user, and then PR sleep. PR sleep is the consumption power. P consumption power of sleep mode of RRAs. PR active is the consumption power of RRAs in active mode. PR transition is the consumption power of RRAs in during the transition modes. WREU is actually beamforming weights. HRRU is the channel gain of channel gain. ST is a state. AT is the action, and then RT is the reward in time slot T. The equivalent SINR at receiver of EUU according to the beamforming antenna is FU is equal to the channel gain and then weights square divided by the interface plus noise. According to the shunt capacity of UE, U is defined as follows. CU is equal to bandwidth into log 2 plus 1 plus FU divided by lambda. M. The transition power is total power is equal to transmission power, active power plus sleep power plus transition power. The state action and reward of proposed DRL algorithm is state has two components. One is the user demand and another one is the active or sleep status of RRH. The action is actually the status of HRRAs for turning on or turning off to obtain the active set of RRAs. Reward is immediate reward is RT, which is calculated by simultaneous minimizing the network in energy uses by satisfying the UE demands. This is the actually proposed algorithm. From environment we will get the some state action reward and then next state, which is actually stored in the replay memory. We use two network. One network one is actually the input is state one, state only. The and then output is actually number of queues. In network two, input is state and action. Network output is only queue value. So from this from the replay memory, we select a mini base, and from this mini base we at first we actually we use input state next as an input in network one, and then this output is action next, and this action next will be input within the state next in network 2. Then q1 and q2 will come. From the q1 and q2 we will actually select the qt by and then finally actually we by using the model we will get the loss of network 2, and this qt actually and the system will be updated. This qt actually will apply for network 1 target, and by this process we will get the network 1 loss, and this network will be updated. Finally the output will come for the network 1. So here we already discussed everything. And the most important things, the C beam pumping system, actually we minimize the power, minimize the transmission power by using which the CNR will be will be maximum by this way, and then power will be minimized by this way, and by this way. And the performance evaluation, the simulation environment is in TensorFlow 1.14 in Spider IDD3, and for ensuring the achievement of our proposed method, we have considered 5 different scenarios. First one is RRH6. UE number is 3. Second one is RRH6, UE number is 4. Third one is RRH8, UE number is 4. And fourth is RRH12, UE is 15. RRH20, UE is 6. The channel, we consider the channel bandwidth B is 10 megahertz. The maximum transmission power is 1 watt. Active power is 6.8 watt. Sleep power is 4.3 watt. And transmission power is 3.0 watt. Transition power The background noise is minus 102 dBm. Antenna gain is 9 dBi. Log normal shadowing is 8 dBi. Rennings small scale fading is CN01. Path loss is equal to 148.1 plus 36.6 log 2 d distance dBi, and then power amplification efficiency is 25. And actually this is our performance evaluation. This is our performance evaluation. In this performance evaluation in figure 3, actually DQ and safe 17.03%. The proposed method DRL save 18.78 more power than FPL traditional method at 10 Mbps user demand in scenario 1. For scenario 3, the percentage of save energy by DQN is 15.2, while it is 19.2 by the proposed method. In scenario 5, we have considered the high state dimension 26 to increase the complexity here. DQ and save 9.45 more power than FPA, while the proposed method save 12.24 power. The power consumption increased professionally concerning the increment of UAS demand. In simulation environment, the proposed DRL algorithm have shown the traditional DQ shown the better performance based on the traditional EQ, DQ, and then evaluation. And now this time, actually, how we presented the parameter, we actually fixed the parameter. This is the present is here. Actually, we have 0.9 the user gamma. For selecting the gamma, I use 0.9 to 0.99. The suitable is 0.95. And then for tuning the tuning the learning rate, I use 0.01 to 0.0004. The suitable one is 0.001. And then actually I will tune the tau, which is really important for our proposed method. The suitable tau is 0.025. This paper is actually in this paper we actually add two value-based network for RRAs of IoT. But the network to the target value of for Q1 are generated, which is actually at the training at for training the network one. It gives the better advantage to optimize the simulation results and handle the complexity. As a result, our proposed DRL have shown the better performance than traditional DRL, and then FA to minimize the total power consumption by satisfying the DEU demand in all simulation area. Thank you so much to consider. Thank you so much.